Okay, quadratic functions have many practical uses. Okay, one is they can be used to model projectiles, objects being thrown, kicked, or tossed. The vertical motion problems talk about an object falling to earth. Okay. Now, on real life applications, we do not use the negative zeros because we would not have negative time. Okay, does everybody understand that? Things to remember when completing quadratic applications. T is in time, that's going to be your x, and that's measured in seconds. H is, or D is height and distance, it represents feet. When an object is in the ground or at water, it's equal to 0 for its height. Anytime, so this is like the velocity and the initial height. Anytime you're doing this, we will give you the problem. Okay, you won't have to like write the problem in this class from the graph. We will give you the problem to plug and chug or to work out. Okay, any questions on that? So let's look at this little chart over here. Okay, this is a 0, but it's negative, so we throw it out because it's a negative 0 and you can't have negative time. The y-intercept is how high off the ground the object starts. So your y-intercept is your initial value, and that's what it is on the graph anyway, right? The y-intercept, if you recall, is your starting point. Remember, in linear functions, you always start with the y-intercept. And so that's your initial, how high it is off the ground. Your vertex, the x value, tells you when, how long it took to get to that highest point, and the y tells you how high the object went. Okay, your positive 0 tells you when the object hit the ground and how long it took to get to the ground. Okay, so that's what that means. All right, so let's look here. How long is the rocket in the air? So it started at 0 and it landed over here at 8 seconds. Any questions on that one? What is the greatest height? Well, we know the greatest height is going to be at our vertex, and somewhere around 255. Now, if you had 257, 260, you're good, okay? How high is the rocket at 1 second? You go to 1, you go up, where is this right here? About 115. Is that making sense? After 2 seconds, 2, go up right here, 185. What's happening to the rocket at that point? It's going up. And then if we go over to 6, it's the reflection of that one, and now it's going down. Any questions on reading the graph? Okay, so let's go to the next page. Okay, after t seconds, a ball is tossed in the air from ground level, reaches a height of this, okay? What is the height of the ball after 3 seconds? What would I do there? Plug 3 in place of t, right? So I would have h of 3 equals 144 times 3 minus 16 times 3 squared. So just like on the graph, you would have went to 3 and went up and found the answer. If you have a function, you just plug 3 in and solve for y. So when you plug that in, what do you get? Okay, 432. You're doing it step by step. Thank you. No, 16 times 9. Minus 144. And so I get 288 feet. So I know after 3 seconds, the ball would be 288 feet off the ground. Does that make sense? I could have also plugged this into my calculator and went to where x is 3 in my table to check it and got 288. Okay. After how many seconds will the ball hit the ground? What is the height of the ground? 0. So I'm going to put 0 in place of h. Do you see how the h is here? That's the height. So I'm going to put 0 in place of h equals 144, and I'm going to change mine to x's because I don't like t's. What would I do here to solve? Feel free to jump in. Yes, Kaden? I have to factor. I know how much y'all love it. So I'm going to take out a 16 and an x. And when I divide out 16, 144 divided by 16 is 9. 16 divided by 16 is 1. And then there is an x left equals 0. Everybody good there? So I have two factors here. So I put 16x equals 0. Divide by 16. So x is going to equal 0. And then I do 9 minus x equals 0. Subtract 9. Negative x equals negative 9. Huh? Divide by negative 1. So x equals 9. I have two answers, so let's read. After how many seconds? So which one can I throw away immediately? The 0, right? Because that's the initial time that the ball was thrown, right? So that's not after seconds, because no seconds have happened at 0. Does that make sense? So after how many seconds will the ball hit the ground? 9. So at 9 seconds, the ball will hit the ground. Okay, does that make sense? All right, let's look at one more. A rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. Where's the maximum height going to be of this rocket? No, that's the initial. Look. Okay, hill. This is 80. This is 0, 80. That's where it's initially. And then it's going to fall to the ground after reaching its maximum height. What's the maximum height? I know, what is the maximum height? What do we call it? We don't know it yet. It is the vertex. So we got to find out. We didn't tell us what the maximum height is. So how long does it take the rocket to reach its maximum height? So is how long x or y? X, because x is time. Y is how high. Everybody good with me? So I am looking for the x of the vertex because that would tell me how long it took to reach the maximum height. So that's the x of the vertex. How do I find the x of the vertex? No, what does factoring give me? Factoring gives me my zeros, right? Put it in vertex form. How do I do that? Huh? But I don't know it. Yeah, what do I use to find the, if you're at home and you know the answer, say, very good. Remember to find the x of your vertex, you use negative b over 2a every single time. Remember that? You got to learn that. So, what's my b here? So that'd be negative 64. And then what's my a? Negative 16. So that'll be negative 64 over negative 32, which equals 2. What if I got a negative 2 there? It'd be wrong. Can I have negative 2 seconds? No. No. So if you get a negative for your time, you are wrong. We have not built a time machine, so we're not going backwards, okay? So if you get a negative, don't go, well, I guess this is a crazy problem. Go, I guess I'm crazy, I need to redo it. Okay? Okay, I think that's something too. All right, now, so that's how long, that's the x of the vertex, how long it took to get to that height. Now I need to find the maximum height. What would that be? The y part, right? The height is the y of the vertex. You're good. So this is the y of the vertex because it's asking how high. How would I find it? Plug in 2. So I have h of 2 because I know that the vertex is at 2. So then I plug in 2 in order to solve for the y. And guys, parabolas are used for bridges. They're used for lots of things because they allow some give. And so a lot of engineering. So put that in your calculator. Does everybody understand what I did? I took this 2 that I solved and plugged it into this original equation. What'd you get? 144 feet. And this is 2 seconds. All right, everybody good there? Okay, we're not going to do this one because I've decided that I wanted to, but I just decided since we don't have a lot of time, we're not going to do that part. All right, one more page and we're done. This here is just a neater graph of that first one we did, so just ignore that, but I put it in there twice just to make sure you understood it. All right, so we are going to look at these 4 problems right here. I want every one of you, okay, so let me tell you what your answer is going to be. So you're going to do it on your own, then we're going to go over it. You're either going to put X at the vertex. So the problem's talking about the X value at the vertex. Does that make sense? Or the problem's talking about the Y value at the vertex. Or it's talking about the 0. So read the problem and tell me which one you think it is. One of those 3 options. Does everybody understand that? What 3 options I'm talking about? X at the vertex, Y, see them right here in that black, or positive 0. So read the problems and decide, and then we're going to talk about it. You have to read the problem, then you pick which one it is based on the problem. All right, guys, so we're going to finish up here. Jack wants to know how high the soccer ball went. So how high is the Y? Okay, that's in the feet. So how high it went will be here on your vertex. So Y at the vertex. So remember, Y is how high, X is how long, the time. Lily wants to know how long her toy rocket will be in the air. So the total time it will be in the air, here's where it started, here's where it landed. So that's our positive 0. Positive 0, because this could be a negative. All right, Nancy is trying to find out how many seconds. So we know we're talking about the X because it's time. It will take the golf ball to get to its highest point. So we're talking about X at the vertex. X at the vertex. Bill is wondering how long, talking about time, it will take a football to hit the ground. So that's at 0. So our positive 0. Reach out if you have questions.